Welcome back to Interstellar Archives. Tonight we will be taking through a long and thorough journey through the world of comets, so lay back, close your eyes, and enjoy the video. Comets are the ancient wanderers of the solar system, icy survivors from its chaotic birth. They are not planets nor asteroids, but something in between, fragile bodies made mostly of ice, dust, and rock that have remained unchanged for billions of years. Their orbits take them far beyond the reach of the sun's warmth, into the frozen outskirts of the solar system, where they slumber for eons until gravity or chance sends them inward. When they do awaken, they carry with them the pristine ingredients of a time when Earth itself was only dust and fire, making them not just celestial objects, but living records of our origin. As a comet approaches the sun, the heat begins to transform it. The frozen gases within the nucleus, carbon dioxide, methane, ammonia, and especially water, start to sublimate, turning directly from ice to gas. This violent process erupts through cracks in the comet's crust, spewing jets of vapor and dust into space. These eruptions build a vast, glowing envelope around the nucleus called the coma, which can grow tens of thousands of kilometers wide, dwarfing the comet itself. The coma then blossoms into the comet's tails, stretching millions of kilometers across the void and turning a small, icy core into a skywide spectacle visible even to the naked eye. One of the most fascinating features of comets is that they form not one, but two tails. The dust tail, created by particles pushed away by the pressure of sunlight, appears white or yellow, curving gently along the comet's orbit. Meanwhile, the iron tail, made of gases stripped of their electrons by solar radiation, is pushed directly away from the sun by the solar wind, glowing blue as charged particles stream into space. No matter which way the comet is moving, both tails always point away from the sun, a counterintuitive truth that astonishes first-time observers. Though they look magnificent from Earth, comets are deceptively small. The solid nucleus at their heart often measures only a few kilometers across, roughly the size of a mountain. Yet, when sunlight awakens them, their activity creates comas and tails so immense they can span more than 100 million kilometers, longer than the distance between Earth and the sun. This dramatic transformation makes comets one of the greatest examples of small things producing enormous effects, amplifying their presence far beyond what their size should allow. Most comets spend their lives in the outer solar system, locked in distant reservoirs of ice. The Kuiper Belt, a ring of icy bodies beyond Neptune, is home to many short-period comets, which return to the inner solar system every few decades or centuries. Even farther away lies the Oort cloud, a vast spherical shell of frozen objects that may stretch halfway to the nearest star. Long-period comets are born here, wandering for millions of years in the cold before being nudged inward by passing stars or the gravitational tide of the Milky Way. These rare visitors remind us that our solar system does not end where the planets stop, but extends into unfathomable realms of darkness and ice. Every time a comet swings near the sun, it loses part of itself. Eruptions chip away at its icy nucleus, scattering dust and gas that form its spectacular tails. Over countless passes, a comet can erode to nothing, disintegrating entirely or leaving behind only a dark, rocky fragment. In this way, comets are both eternal and fragile, billions of years old, yet easily destroyed in the blink of cosmic time. Their beauty comes at the cost of their own existence, and every comet we see is slowly burning its way toward oblivion. But even as they die, comets leave gifts behind. The dust and debris shed along their paths remain in space long after they have moved on. When Earth's orbit crosses these trails, the particles plunge into our atmosphere at tremendous speeds, igniting as meteors. Thus, meteor showers are the lasting fingerprints of comets, transforming their lost fragments into streaks of light that rain across the night sky. Each August, the Perseid meteor shower marks Earth's passage through the trail of Comet Swift-Tuttle, turning an ancient comet's remains into one of the most spectacular celestial shows visible from our planet. The darkness of a comet's surface is another of its mysteries. Though their tails shine brilliantly, the nuclei themselves are some of the blackest objects in the solar system. Covered in tar-like organic compounds, they reflect only a few % of the sunlight that hits them, darker even than charcoal. This cloak of carbon-rich material hides beneath it layers of pristine ice, creating a deceptive contrast between the brilliance of a comet's appearance and the shadowy reality of its body. It is as though comets are cloaked in cosmic soot, carrying within their cores the secrets of chemistry that may have seeded life on Earth. Indeed, one of the most profound theories in science is that comets helped deliver the building blocks of life. Early in Earth's history, when the planet was still cooling from its violent formation, comets may have bombarded its surface, delivering vast amounts of water and complex organic molecules. If true, our oceans, and perhaps even the molecular seeds of biology itself, may have begun as cometary gifts. In this vision, every drop of water that fills our seas and every cell that breathes within us is a relic of these icy wanderers, making comets not just visitors, but ancestors. For ancient civilizations, comets were not scientific curiosities, but terrifying omens. Their sudden appearance in the sky, seemingly out of nowhere, disrupted the steady cycles of stars and planets. To rulers and priests, a comet was a harbinger of disaster, foretelling the fall of kings, the outbreak of plagues, or the destruction of cities. Chronicles from China, Europe, and the Middle East are filled with accounts of comets striking fear into entire populations. Though we now know their appearances are natural, this cultural memory lingers, reminding us how deeply comets are woven into human imagination. Comets are shaped not only by the sun's heat, but by the invisible hand of gravity. Each time they pass through the inner solar system, the planets tug on them, subtly shifting their orbits. Jupiter in particular plays a commanding role, often acting as both a shepherd and a destroyer. Its immense gravity can fling comets out of the solar system entirely, or capture them into shorter, repeating orbits. Many of the short-period comets we know today were sculpted into their paths by encounters with the gas giant, showing how even icy wanderers are ultimately subject to the dominance of planetary gravity. Sometimes, this gravitational tug-of-war ends catastrophically. A comet that ventures too close to Jupiter can be torn apart by tidal forces, splitting into fragments that trail one another through the sky like glowing pearls on a string. This happened to Comet Shoemaker-Levy 9 in 1994, when it was ripped into more than 20 pieces before colliding spectacularly with Jupiter's atmosphere. The fiery scars left behind were visible for months, a reminder that comets are not untouchable ghosts but fragile bodies vulnerable to the immense powers of the cosmos. Despite their fragility, comets can also endure astonishing journeys. Long-period comets arriving from the Oort cloud may travel for millions of years before returning to the inner solar system. Their paths extend so far into the galactic tide that the faint gravity of passing stars can redirect them. Each one that reaches us is a survivor of countless perturbations, an emissary from the outer edge of our star's dominion, bearing witness to the interactions between stellar systems scattered across the galaxy. For scientists, comets are laboratories in motion. When probes such as the European Space Agency's Rosetta mission visited Comet 67P, they discovered landscapes unlike anything on Earth: towering cliffs, yawning pits, and plains strewn with boulders. Jets of vapor burst from vents in the surface, spewing gas and dust into space like geysers. The Philae lander, though it struggled to anchor itself, confirmed that the comet's crust was both hard and porous, a paradoxical combination that revealed just how alien these bodies are. These missions transformed comets from distant streaks of light into tangible worlds with surfaces that could be touched, mapped, and studied. Even the chemistry of comets offers tantalizing clues. Analysis of cometary material has revealed a wealth of complex organic molecules, including amino acids, sugars, and other precursors to life. These findings strengthen the idea that comets may have delivered not just water but also the chemical ingredients for biology to the early Earth. In this sense, every comet that passes near us is not just an icy body but a capsule of cosmic possibility, carrying within it the seeds that could ignite life wherever they land. Yet comets are also masters of disguise. Their dazzling tails make them appear vast and luminous, but in truth, the coma and tail are ephemeral, composed of diffuse gas and dust spread across millions of kilometers. If you were to stand near a comet's nucleus, the tail would not look like a solid streak, but more like a faint mist, ghostly and transparent. Their beauty is a trick of perspective, an interplay of sunlight and particles that from afar creates one of the most breathtaking sights in the heavens. Throughout history, certain comets have become legends in their own right. Halley's Comet, the most famous of them all, has been recorded for more than 2 millennia, appearing every 76 years like clockwork. Its presence has been tied to great battles, the rise of empires, and even works of art, such as its depiction in the Bayeux tapestry. Generations have gazed upon Halley's return, knowing that it is one of the few cosmic events that links humanity across centuries. Its next visit, in 2061, will be yet another moment of continuity between the distant past and our unknown future. Some comets, however, never return. These one-time visitors plunge toward the Sun on paths so elongated that they will not reappear for millions of years, if ever. They streak through the night sky, dazzling humanity for weeks, and then vanish back into the abyss. For those lucky enough to witness them, these rare apparitions are reminders of the transience, of beauty in the cosmos spectacles that come once in a civilization's memory before retreating to silence. Others never make it past their encounter with the Sun. Sun-grazing comets dive perilously close, skimming the star's surface at thousands of kilometers per second. Some survive these death-defying passes, their tails flaring with renewed brilliance. Others disintegrate completely, torn apart by the Sun's heat and gravity, leaving nothing but a brief blaze of glory. These sacrifices to the star illustrate the danger comets face in their restless orbits, forever at the mercy of the very force that gives them light. The study of comets is not just about understanding them, it is also about understanding us. By tracing their orbits, scientists can learn about the gravitational architecture of the solar system. By analyzing their chemistry, we gain insight into the conditions that gave rise to life. By watching their interactions with planets and the Sun, we see the solar system as a dynamic, ever-changing environment. Comets, in their ephemeral beauty, are reminders that the cosmos is not static but alive with movement, collisions, and transformation. Comets are like nomads traveling between realms, neither fully part of the inner solar system nor entirely belonging to the dark outskirts. They drift in limbo for most of their existence, frozen solid in the blackness beyond the planets, until a gravitational nudge sets them on a long voyage inward. In this way, every comet we see is on a rare pilgrimage, passing through the sunlight only briefly before retreating again to the shadows. Their orbits can span distances so vast that even light itself would take months to cross them, yet they return faithfully, obeying the silent laws of gravity. The orbits of comets are highly eccentric, often stretched into elongated ellipses that sweep them close to the Sun before flinging them far back into the outer darkness. This dramatic dance creates a cycle of dormancy and activity. They sleep for centuries in the cold, then flare to life in a blaze of light when they near our star. Unlike planets with steady rhythms, comets embody extreme icy silence, broken by fiery brilliance, stability punctuated by chaos. Their very existence is a reminder of how diverse and unpredictable the solar system can be. Though comets are ancient, they are also ephemeral. Each pass by the Sun strips away part of their mass, eroding their nuclei little by little. Over time, this attrition leaves behind only ghostly fragments, and eventually, nothing at all. Some break apart dramatically, scattering debris into space like shattered glass. Others fade more quietly, becoming dormant and indistinguishable from asteroids. The comets we see today are the survivors, but each one carries within it the certainty of eventual death. Their brilliance, fleeting and temporary, mirrors the impermanence of all things. Meteor showers are perhaps the most personal gift comets leave behind. When we lie on a summer night and watch streaks of light carve the sky, we are witnessing the remains of a comet's passage. Fragments no bigger than grains of sand colliding with our atmosphere. The Perseids, the Leonids, the Geminids, all of these dazzling showers are the handiwork of comets, scattering dust in their wake. These showers turn ancient debris into moments of wonder, transforming lifeless particles into brilliant, fiery art because they are unpredictable. Comets have always held humanity's attention in a special way. A star might rise and set predictably for millennia, but a comet can appear out of nowhere, blazing into the night as if summoned by the gods. In ancient times, this suddenness made them terrifying. Kings and emperors feared their arrival as signs of doom. Yet in modern times, the same unpredictability inspires awe and curiosity. They remain messengers from the unknown, bridging the gap between terror and wonder across human history. One of the strangest things about comets is their dual nature. They are both fragile and powerful. A comet nucleus is soft enough to crumble under a spacecraft's landing gear. Yet when fragments of comets strike planets, the energy released can be cataclysmic. On Earth, cometary impacts may have triggered mass extinctions or altered the climate in profound ways. On Jupiter, the The impact of Shoemaker-Levy 9 carved scars larger than Earth itself into the planet's clouds. These icy wanderers may look delicate, but in the wrong circumstances, they wield the destructive power of worlds. Astronomers have catalogued thousands of comets, but the number that exists in the solar system is vastly greater. Trillions may lurk in the Oort cloud, a realm so far away that we cannot see it directly. This invisible population is like a hidden army, waiting in the darkness, their fates governed by faint nudges of gravity. When one falls inward, it carries with it the weight of unimaginable distance, a traveler that has crossed the boundary between interstellar space and our own celestial neighborhood. Each comet we see may be the only one of its kind to grace human eyes. Technology has allowed us to study comets like never before. Telescopes on Earth and in space can track their composition, their outbursts, and their unpredictable changes. Missions like Rosetta have shown us their surfaces in unprecedented detail. Yet despite these advances, comets remain elusive. They defy easy predictions, brightening or fading in ways that often surprise astronomers. This unpredictability keeps them mysterious, forcing us to treat each comet not as a known object, but as a unique world with its own character and story. The icy cores of comets are surprisingly porous, filled with voids and fragile structures. This porous nature makes them poor conductors of heat, which is why they can preserve volatile compounds for billions of years. It also makes them unstable, prone to eruptions and collapses. Some comets suddenly flare in brightness as hidden pockets of gas explode outward, creating temporary fireworks. Others may split apart, leaving smaller daughter comets trailing in their wake. These violent behaviors reveal that comets are not passive relics but active, dynamic bodies, constantly reshaping themselves. Comets are also time travelers in a sense. When one visits the inner solar system, it brings with it not just ice and dust, but the chemical conditions of a time long gone. By analyzing the isotopes of water in comets, scientists compare them with Earth's oceans, trying to determine whether our water has cometary origins. Some matches have been close, suggesting that at least part of Earth's water may have arrived this way. If true, it means our planet sees the foundation of life, our gifts from these cosmic wanderers. The light of a comet's tail may look solid from afar, but if you could drift within it, you would find yourself surrounded by an invisible haze. The particles are spread so thinly that you could fly a spacecraft through the tail without harm, passing through millions of kilometers of glowing dust that feels more like mist than matter. This paradox, something that looks solid but is actually nearly empty, is one of the illusions that make comets so enchanting. They embody both grandeur and fragility, beauty born from emptiness. In myth and legend, comets are often seen as travelers from another realm, carrying messages from gods or spirits. Some cultures believed comets were fiery swords slashing through the heavens, symbols of war or divine anger. Others thought they were celestial brooms, sweeping away the old to make way for the new. These interpretations reflect how comets disrupt the normal order of the sky. Unlike planets and stars, which move predictably, comets refuse to conform, and in that refusal, they inspire stories that endure across generations. Even in modern times, comets can stir public excitement like few other celestial events. When Comet Hale-Bopp blazed across the sky in 1997, it was visible for months, bright enough to see without binoculars. Millions of people around the world gazed up night after night, reminded of their place in the cosmos. For many, it was a once-in-a-lifetime event, a communal moment of wonder that transcended borders and languages. These shared experiences are part of what makes comets unique. They unite humanity under one sky, inspiring awe on a global scale. The life cycle of a comet is a slow transformation from ice to dust. As material boils away, what remains can eventually resemble an asteroid more than a comet, dark and inert. Some asteroids in the inner solar system are believed to be the fossilized remains of extinct comets, their icy past betrayed only by faint traces of activity. In this way, the boundary between comet and asteroid is not always clear. These categories are more fluid than rigid, blurring the lines between frozen wanderers and rocky worlds. Sun-grazing comets belong to a particularly dangerous family. Their orbits take them within a few thousand kilometers of the Sun's surface, where the intense heat and tidal forces push them to their limits. Many disintegrate completely during their passage, consumed by the star's power. Yet those that survive emerge spectacularly, their tails blazing even brighter than before. These close encounters with the sun highlight the extremes of cometary endurance, where destruction and survival are decided in an instant. When comets are photographed up close, their landscapes look surprisingly familiar. Towering cliffs, eroded valleys, and fractured plains echo features we might see on Earth or Mars. Yet these landscapes are sculpted not by wind or water, but by sublimation and collapse. The resemblance is uncanny, reminding us that nature often shapes different worlds in parallel ways, even when the forces at play are completely different. Looking at a comet's terrain feels like glimpsing an alien Earth, one shaped entirely by ice and sunlight. Even the names of comets carry stories. Many are named after their discoverers, immortalizing the astronomers who first spotted them. Others bear the names of spacecraft or observatories that revealed their paths. These names remind us that comets are not only natural phenomena, but also milestones in human discovery. Each one represents the efforts of countless stargazers who scanned the heavens, eager to catch sight of something fleeting and extraordinary. Comets are unpredictable, partly because they are governed by so many competing forces. Solar radiation, gravity, spin, and eruptions all interact in ways that defy simple calculation. Sometimes a comet brightens far more than expected, delighting observers. Other times it fizzles, failing to live up to predictions. This unpredictability makes them both frustrating and thrilling to study. Each comet is its own experiment, unfolding in real time, reminding us that the universe is not a machine of perfect order, but a realm of surprises. The possibility of capturing a comet for study has long fascinated scientists. While Rosetta orbited its comet and Philae briefly touched down, no mission has yet returned with large samples. Future plans imagine harvesting cometary ice and dust directly, storing it in sealed chambers, and bringing it back to Earth. Such material would be a treasure chest of primordial matter, allowing us to hold in our hands the very building blocks of the solar system. This dream reflects humanity's growing ambition to not only observe comets, but to make them part of our story in a tangible way. Finally, comets remind us of the interconnectedness of the cosmos. They are not confined to one role or one place. They are couriers of water, bringers of destruction, seeds of life, and objects of fear and wonder. They belong to both the scientific realm and the mythic imagination, carrying within them the essence of cosmic duality. They are small yet vast in influence, fragile yet capable of reshaping worlds. To study comets is to glimpse the poetry of the universe, written in ice and dust, fleeting yet eternal. Comets are frozen oracles of time, carrying within their icy shells the whispers of creation itself. When they sweep into the inner solar system, they awaken from slumber, and in their outgassing trails, they release the chemistry of the early universe. These trails are more than decoration. They are libraries of ancient molecules, preserved since before Earth was born. To study them is to eavesdrop on the very first chapters of the solar story, a glimpse of the raw materials that once swirled in a protoplanetary disk. The sight of a comet crossing the night sky has always triggered something primal in humanity. Unlike planets, which wander predictably, or stars, which seem immovable, comets arrive uninvited. Their sudden appearance pierces routine, as if the heavens themselves want to remind us of their power to astonish. To ancient eyes, they were omens of death or kingship, while to modern eyes they are messengers of science. Yet at their core, they remain the same, celestial intruders, breaking monotony with brilliance. In their darkness, comets store volatile gases like carbon dioxide, carbon monoxide, and methane. When these ices vaporize near the sun, they don't just form tails, they create a temporary atmosphere, a fragile and ghostly coma that dwarfs the solid nucleus itself. This coma glows with fluorescent light as it absorbs and re-emits solar radiation, making the comet look alive. A comet's apparent size in the sky, though faint, can rival or even exceed that of planets. They'd become worlds cloaked in halos, crowned by light. Some comets are captured into short orbits, circling the sun every few years, while others take millennia to return. Still others may pass through once and never return, their orbits stretched into open parabolas by Jupiter's immense gravity. These one-time visitors are like shooting stars on a cosmic scale, brief, dazzling, and gone forever. The tragedy of these single-pass comets is that they offer us just one performance. When their light fades, it is for eternity, lost to interstellar exile. The tails of comets are not singular but dual. Dust tails scatter sunlight like a celestial fan, while ion tails glow with an electric blue light, sculpted by the solar wind into streams of plasma. These twin tails stretch for millions of kilometers, always pointing away from the sun, as though the star itself is chasing the comet outward. They give the illusion of directionality, like arrows pointing to the edge of the cosmos, reminding us that the sun governs everything within its reach. Occasionally, comets surprise observers with violent outbursts, brightening hundreds of times over in a matter of hours. These eruptions are caused by sudden collapses, pressurized gas vents, or structural breakages within the nucleus. To witness such a flare is to feel the comet's pulse, its chaotic heart beating against the vacuum. For astronomers, these unpredictable surges are both frustrating and exhilarating, rewriting predictions and forcing us to accept that comets are living, reactive bodies, not passive rocks. While comets are often painted as harbingers of disaster, they may also have been the architects of life. Some theories suggest that comets seeded Earth with complex organic molecules, delivering amino acids and sugars that laid the groundwork for biology. If true, then humanity itself owes its existence to the icy wanderers. Every cell in our body, every strand of DNA, might carry the faint chemical fingerprints of cometary origins, binding us forever to the long arcs of their journeys. When spacecraft first photographed the surfaces of comets, they revealed worlds that looked almost sculpted by imagination. Dark, charcoal-like terrains dotted with cliffs and pits gave them the appearance of ancient ruins. Craters, ridges, and fractured plains looked eerily like alien landscapes from science fiction, but the truth is stranger than fiction. These features were carved not by tectonics or weather, but by sublimation, the slow, invisible escape of gas carving entire valleys over eons. The survival of a comet depends on a delicate balance between fragility and persistence. Some vanish after only a few trips around the sun, crumbling into meteoroid streams. Others endure for tens of thousands of years, defying their fragile constitution. This disparity means that every comet we observe is a statistical miracle, a survivor that has lasted long enough to cross our gaze. Their presence in our sky is not guaranteed but gifted, a brief alignment of chance and endurance. On occasion, comets collide not with planets but with each other, creating fragments that wander independently. These fragments sometimes follow each other like siblings across the night sky, creating double or triple comets visible from Earth. To see two glowing tails side by side is a rare celestial spectacle, one that blurs the line between astronomy and art. It is as if the cosmos itself has decided to paint the heavens in broad strokes, using comets as its brushes. Comets challenge our sense of permanence. A mountain, an ocean, even a continent may seem eternal to human eyes, but a comet shows how quickly a body can transform. Within a single orbit, cliffs collapse, geysers erupt, and landscapes alter dramatically. To study comets is to watch geology accelerated to breathtaking speed, to see entire worlds reshaped within the span of a few decades. Their impermanence is their identity, fleetingness their truth. When comets dive close to the sun, they sometimes disintegrate in brilliant displays of cosmic sacrifice. These sun grazers flare spectacularly as they near the star, their tails stretching brighter and longer, only to vanish completely. To astronomers, this destruction is both tragic and beautiful. The comet dies, but in its death, it gives one final burst of radiance, a farewell written in fire. Their sacrifice becomes our spectacle, a fleeting blaze that will never repeat. Jupiter plays the role of both shepherd and executioner of comets. Its immense gravity often captures them into shorter orbits, transforming once infinite travelers into repeat visitors. Yet the same gravity can also tear comets apart or fling them entirely out of the solar system. The gas giant is both guardian and destroyer, deciding which comets stay and which are banished. This dual role makes Jupiter the silent arbiter of many cometary fates. The idea that comets might have cousins in other star systems is an exciting frontier. Astronomers have already spotted interstellar visitors like Oumuamua and Borisov, objects likely born around other suns. If they are comets, they remind us that icy wanderers are not unique to our system but universal, common byproducts of planetary birth. Their presence hints at billions of cometary nomads drifting between stars, carrying the chemistry of countless worlds across the galaxy. As a comet approaches, astronomers can predict its path, but its brightness is always a mystery. Some expected spectacles fade into obscurity, barely visible even with telescopes. Others unexpectedly ignite, dazzling the world with naked eye glory. This unpredictability makes comets events of chance, not certainty. To see one shining brightly above your horizon is to witness fortune itself, an alignment of both physics and luck. In their icy silence, comets know nothing of human fear, yet they have been blamed for wars, plagues, and disasters throughout history. The arrival of Halley's comet in 1066 was seen as an omen of the Norman invasion of England. In 1910, its return sparked mass panic as rumors spread that its tail contained deadly cyanide gas. Though we now know better, the emotional power of comets remains undeniable. They still stir awe, dread, and wonder in equal measure. The study of comets is not just about astronomy, but about humility. They remind us of how small and temporary our species is compared to the grand cycles of the solar system. Some comets take 200,000 years to return. Civilizations will rise and fall. Languages will vanish. Entire species may evolve. And yet the comet will still be making its slow arc. To contemplate such timescales is to realize that our stories are but brief flickers against their journeys. A comet's dust trail lingers long after it has passed, continuing to cross Earth's orbit year after year. This persistence gives us meteor showers, events that turn night skies into sparkling performances. Every streak we see burning in the atmosphere is the remnant of a comet, a glowing eulogy for a body that shed itself across the heavens. These showers are both funerals and celebrations, lighting up the sky with reminders of cosmic impermanence. The very darkness of a comet's nucleus is another paradox. Despite their luminous tails, their surfaces are among the darkest objects in the solar system, blacker than coal. This is because the ice within is coated with organic compounds and dust baked by sunlight into a tar-like crust. Beneath that crust lies the pure brilliance of water ice, but the surface hides it like a mask. Comets are luminous only when they are breaking apart. Their beauty is born from their destruction. Finally, comets are more than just frozen rocks. They are cosmic storytellers. Their orbits, their chemistry, their tails, and even their deaths tell us about the origins of planets, the migration of worlds, and the connections between stars. They are both relics and prophets, holding the past and hinting at the future. To chase a comet is to chase meaning itself, to pursue not just an object, but the story it carries from the edge of the universe. When comets drift close to Earth's orbit, they give us something more than light. They give us a cosmic handshake. Meteor showers born from their dust become nights where humans reconnect with the universe. Every streak across the sky is a grain that traveled millions of years before burning out in an instant. A reminder that we, too, are sparks in the vastness. Entire cultures have stood beneath these glowing rains, weaving myths of fire serpents, arrows from the gods, or spirits of ancestors returning. Though fragile, comets wield immense power. A comet's impact could release energy greater than 1,000 nuclear bombs, reshaping landscapes and altering climates. Some scientists believe comets were responsible for catastrophic floods or even mass extinctions in Earth's past. They are paradoxical beings, messengers of life through water and organics, and harbingers of death through devastation. To stand in awe of a comet's beauty is also to acknowledge the lurking danger of its orbit. The surfaces of comets hold hidden geysers, vents where trapped gases suddenly burst free. These jets can hurl plumes of dust hundreds of meters into space, creating miniature volcanoes of ice and vapor. For spacecraft, approaching comets is perilous, as these unpredictable eruptions can knock instruments off course. Yet it is in these geysers that comets reveal their chemistry, spewing out signatures of primordial molecules into space. Their eruptions are not just chaos, they are revelations. In distant mythology, comets were sometimes seen as flaming swords, wielded by gods to punish humanity. Their sudden, bright tails seem to slash across the heavens, as if the universe itself were striking down on Earth. This imagery was so powerful that rulers feared them, believing they foretold their own deaths or the rise of rivals. Even as we have come to understand their science, it is impossible not to look up and see something both weapon-like and divine. The orbits of comets are sculpted by gravitational resonances, especially with Jupiter. Some become trapped in repeating cycles, others are broken into fragments, and some are ejected entirely into the interstellar dark. These orbital dances reveal the unseen architecture of the solar system, the way invisible harmonies of gravity dictate the fates of ice and stone. To trace a comet's orbit is to listen to the music of the spheres, played on timescales too vast for human ears. Sometimes, comets reveal a curious feature: multiple tails. Beyond dust and ion trails, they can also produce sodium or neutral gas tails, each glowing with its own hue. These rare displays make a comet look like a many-headed dragon, spewing streams of color across the night. Each tail tells a different chemical story, a spectrum of reactions between sunlight, particles, and frozen compounds. They are less objects and more symphonies, with every glowing streak a note of light. The Oort cloud, birthplace of most long-period comets, is an almost mythical region. It lies so far from the Sun that no telescope has ever seen it, yet its existence is inferred by the behavior of comets themselves. It is a kingdom of ice in the void, containing trillions of bodies. Some call it the solar system's skin, the outer shell that defines our reach. Whenever a comet falls from this frozen halo, it carries with it the memory of an unseen empire. The cores of comets are far from uniform. Some spin slowly, while others rotate rapidly, causing their jets to spew in spirals or arcs. This spin can sometimes destabilize a comet entirely, tearing it apart as centrifugal force overwhelms its cohesion. These breakups scatter glowing fragments across the sky, turning a single streak into a cluster of lights. For observers, these are rare blessings, a fireworks display orchestrated not by humans but by physics itself. For centuries, comets could not be predicted. Their sudden arrivals terrified kings and thrilled peasants, leaving astronomers helpless. It wasn't until Edmund Halley calculated the repeating path of the comet that now bears his name that humanity realized comets could be tamed by mathematics. Halley's triumph turned chaos into order, showing that even the wildest wanderers obey the laws of gravity. His insight proved that comets were not omens of random doom, but partners in the grand celestial clockwork. When comets cross paths with Earth's orbit, they occasionally deliver something tangible. These tiny grains fall silently through our skies, landing on rooftops, deserts, and ice sheets. Some are collected by scientists and studied under microscopes, revealing complex organics within. In these specks lie the fingerprints of the cosmos, treasures smaller than a grain of sand, yet carrying the chemistry of stars. Every rooftop dusting of cometary material is a gift from deep time. Some comets take on a reddish hue when their dust reflects sunlight in unusual ways. This eerie glow makes them look like embers burning against the black of space. Ancient people often described them as blood comets, associating them with wars and disasters. Yet the truth lies in physics. Microscopic dust grains scattering light differently than expected. Their redness is not a curse but a quirk. Another way comets disguise themselves in costumes of fear and wonder. In rare instances, comets disintegrate completely, leaving no nucleus behind, only a faint smear of dust across the sky. Astronomers call these ghost comets, remnants that appear as fading wisps through telescopes. These deaths are quiet, undramatic compared to fiery impacts or dazzling tails, but in their silence, they are haunting worlds that came billions of kilometers only to dissolve into nothing. To glimpse a ghost comet is to witness the fragility of existence written in light. Comets carry isotopic signatures that sometimes differ from Earth's water, challenging the theory that all of our oceans came from them. Some comets have heavy water, containing deuterium in greater proportions. This complicates the story of life's origins, forcing scientists to look at asteroids and other sources as well. Yet, it may also mean that Earth's oceans are a blend, a patchwork of gifts from many wanderers. Every wave we see could be a comet's legacy mingled with others. The brightness of a comet often depends on its nucleus size. Giant comets, tens of kilometers across, can become spectacularly bright, while smaller ones may pass unnoticed. But size is not destiny. Sometimes even modest comets flare up unexpectedly, outshining predictions. This unpredictability has led to disappointment, but also to astonishment. With faint newcomers suddenly dazzling entire continents, comets refuse to follow our expectations, remaining tricksters of the sky. In the vacuum of space, a comet is silent. But if you were somehow close enough to hear its activity, you might perceive faint crackles and rumbles as gases vent explosively. In fact, spacecraft instruments have detected electromagnetic oscillations that can be translated into eerie, musical tones. These ghostly songs of comets make them feel alive, as if they are humming through the void. They are more than objects, they are performers, singing across the cosmos. Comets often leave behind companion fragments when they fracture. These fragments sometimes follow similar orbits, creating families of comets that share a common ancestor. Over centuries, these families can dominate meteor showers and populate the skies with multiple visitors. Studying these kinships is like constructing family trees in space, tracing the lineage of wanderers. They remind us that even in their destruction, comets give birth to descendants that continue their journey. For some cultures, comets were not omens of doom, but of guidance. The Polynesians, expert navigators of the seas, incorporated comets into their celestial maps. To them, the streaks across the sky were markers of direction, helping them chart courses across vast oceans. Where others saw fear, they saw opportunity. This duality of interpretation reflects the comet's true nature, neither good nor bad, simply a force of nature whose meaning depends on the eyes that behold it. As we look toward the future, comets may become resources for their abundant water ice could be harvested for drinking water, oxygen, and even rocket fuel. A comet could serve as a refueling station on the frontier of exploration, turning a symbol of fear into a beacon of hope. In this way, comets could become stepping stones to the stars, allies in our quest to spread beyond Earth. What was once omen may one day be salvation. In modern culture, comets still ignite imaginations. From tales of star-crossed lovers wishing on their glow to blockbuster movies imagining their collision with Earth, comets embody both romance and dread. They are perfect symbols of impermanence, appearing suddenly, burning brightly, and vanishing into the dark. Their duality makes them eternal muses, inspiring both scientists and artists. To this day, no comet passes without sparking wonder in both telescopes and hearts. When a comet first awakens from deep space, it is like watching a frozen world breathe for the first time in millennia. As it approaches the sun, its ices vaporize into shimmering clouds, and what was once invisible in the dark becomes a radiant spectacle visible across light years. In this transformation, comets act as living metaphors for rebirth, rising from silence into glory. Every outburst is a reminder that even the coldest wanderers carry fire within them. Comets are survivors of cosmic violence, untouched remnants of the protoplanetary disk where planets fought for dominance. While giants like Jupiter consumed vast swaths of material, comets remained hidden at the fringes, never gathered into worlds. This untouched state makes them precious. They are fossils made of ice, carrying the fingerprints of the nebula from which the sun was born. Studying them is like reading an unaltered manuscript of our solar system's first chapter. Some comets fall so close to the sun that they graze its atmosphere, their tails whipping into radiant arcs that can span the sky. These sungrazers often end in fiery deaths, torn apart by tidal forces or vaporized by heat. Yet in their sacrifice, they put on the most spectacular shows, bright enough to be seen in daylight. To watch such a comet perish is to witness a cosmic martyrdom, an object consumed so that others might see its glory in its final breath. The dust released by comets carries not only organic compounds, but also tiny magnetic grains that preserve records of the early solar system's magnetic fields. These particles are like tape recorders of cosmic history, frozen snapshots of forces that shaped planets. When scientists recover these grains in meteorites or dust collectors, they unlock a record billions of years old. Comets, in their destruction, revealed the unseen forces that wove the solar system together. A comet, a glowing shroud of gas around its nucleus, can grow larger than planets. In some cases, it can rival the size of Jupiter, dwarfing the tiny core at its center. From Earth, we see only a glowing dot with tails, but in reality, a comet is a vast sphere of vapor spreading across millions of kilometers. They are giants hiding behind fragile shells, illusions of fragility masking incredible reach. Their presence is larger than our minds can truly comprehend. When comets strike planets, they bring both devastation and renewal. The Chicxulub impactor, which many believe contributed to the dinosaurs' extinction, may have been a fragment of a comet, yet such impacts also deliver water and organics, sowing the seeds for future life. This duality makes comets cosmic gamblers, rolling dice with life itself. Sometimes they end chapters with fire, other times they write beginnings with ice. Either way, their influence cannot be denied. In ancient China, comets were catalogued meticulously, with records spanning thousands of years. Each description, from the color of the tail to its direction in the sky, was interpreted as an omen for emperors and dynasties. These records, though written in the language of myth, are now invaluable to astronomers. They provide data on comets that passed centuries ago, revealing orbital patterns we might otherwise never know. Myth has become science, and the ancients become our colleagues. A comet's tail does not trail behind it, as many imagine. Instead, it always points away from the sun, driven outward by solar wind and radiation pressure. This means that as comets leave the sun, their tails stream ahead of them, as though they are being chased by their own light. This strange geometry defies intuition, reminding us that space obeys rules unfamiliar to earthly eyes. What we see as beauty is also a physics lesson painted in fire. Some comets are so faint they can only be seen with giant telescopes, while others blaze across the sky for weeks, visible even in cities. This variance depends on their composition, orbit, and timing, but also on sheer luck. A bright comet arriving when Earth's skies are clear can ignite global wonder, while an equally brilliant one hidden by clouds passes unnoticed. Comets remind us that the universe doesn't bend to human convenience. Its wonders arrive on their own terms. Occasionally, comets seem to sprout multiple nuclei. These split comets occur when a nucleus fractures, creating smaller companions that follow the parent. Through telescopes, these look like ghostly caravans, each fragment trailing its own miniature tail. Over time, some fade, while others endure, forming legacies of broken wanderers. It is as if the comet reproduces not biologically but catastrophically, birthing heirs through destruction, passing on its journey to fragments. Instruments aboard spacecraft have revealed that comets smelled terrible sulfur compounds, ammonia, and formaldehyde waft from their surfaces, creating a stench of rotten eggs and alcohol. Though the vacuum of space prevents us from directly experiencing it, the molecules themselves tell the story. Comets are chemical cauldrons, mixing the sweet scent of alcohol with the bitterness of sulfur. Their perfume is one of contradictions, a bouquet of life's building blocks wrapped in decay. The icy crust of comets hides secrets below the surface. Some contain layers of different ices, stacked like the rings of a tree. These layers record the history of the comets, heating and cooling, revealing how many times it has visited the sun. To drill into a comet is to read its diary. Each stratum a chapter of journeys past. Beneath the dust, they preserve not only time but memory. Frozen pages of a life measured in orbits. Comets travel at staggering speeds, dozens of kilometers per second, yet from Earth, they appear to drift gently across the sky. This illusion masks their true velocity, the unimaginable pace at which they cut through space. Their grace is a trick of distance, their slowness a lie. In truth, they are cosmic bullets, racing so fast that a single second could carry them farther than an entire city. To gaze at them is to mistake fury for calm. The tails of comets often curve gracefully, shaped by the complex interplay of dust, plasma, and solar wind. This curvature makes them look like brushes painting the night with luminous arcs. No two tails are identical. Each comet sketches its own unique calligraphy across the stars. These strokes vanish quickly, but in photographs and in memory, they remain as celestial art. The universe does not write with words but with light, and comets are its pens. Some comets are interlopers from beyond, not bound to our sun at all. Interstellar comets like Borisov enter briefly, racing through before vanishing forever. These visitors remind us that our solar system is not isolated but part of a galactic sea, where comets drift endlessly between stars. To catch one is to glimpse another world's relic, a piece of alien history passing through our sky. Their presence expands our sense of belonging to a larger cosmic family. In the shadows of comets, scientists also search for clues about dark matter and cosmic dust. The way sunlight scatters off their particles reveals properties of matter that are otherwise invisible. In this way, comets serve as laboratories in space, offering natural experiments on radiation, plasma, and gravity. They are not only relics of creation but also tools of discovery, teachers disguised as wanderers. Their lessons extend far beyond their icy shells. When Halley's Comet returned in 1910, newspapers fueled hysteria by claiming that Earth would pass through its poisonous tail. People bought comet pills and even comet umbrellas, desperate for protection. Yet when the day arrived, nothing catastrophic happened, only a glowing spectacle. This moment highlighted humanity's dual nature, fearful of the unknown, yet irresistibly drawn to it. Even in panic, we could not look away from the beauty overhead. Comets often surprise us by defying expectations. Some fade early, breaking astronomers' hearts, while others flare spectacularly against all predictions. These surprises keep the study of comets alive, ensuring they can never be fully tamed by formulas. They are cosmic tricksters, delighting in playing with our certainty. Perhaps this is their greatest gift, to remind us that wonder thrives best in unpredictability, that not everything can be solved by equations. Ultimately, comets embody the tension between permanence and transience. They are ancient beyond imagination, yet fleeting in their appearances. They are builders of life and harbingers of death. They are ugly in their stench and dazzling in their light. To follow a comet across the sky is to meditate on contradiction itself, to see how the universe balances beauty with terror, fragility with endurance. They are the riddles of creation, written in ice and fire. Comets can act as cosmic messengers, their orbits influenced by distant planets. Sometimes Jupiter's immense gravity captures or redirects them, slinging them deeper into the solar system or tossing them outward to the void. These gravitational dances create celestial highways, routes through which comets are endlessly shuffled. In this way, planets and comets engage in a dialogue, each encounter reshaping destinies written across eons. The brilliance of a comet's tail hides the fact that its nucleus is often no larger than a mountain. This contrast between smallness and spectacle makes comets unique. A frozen rock, sometimes only a few kilometers wide, can command the gaze of millions on Earth. They remind us that size is not always equal to influence, that even the smallest travelers can cast light across the cosmos when placed in the right position. Comets have been described as dirty snowballs, but this phrase downplays their complexity. Beneath the dust and ice are layers of hydrocarbons, minerals, and frozen gases, mixed chaotically in patterns unlike any planet or moon. They are messy archives of creation, their disordered nature preserving what larger bodies lost to geological processes. Calling them dirty snowballs is like calling a library a pile of paper, ignores the richness within. In myth, comets often arrived as heralds of doom, yet in truth they may have sparked the opposite. When Earth was young, they bombarded its surface, delivering not only water but also complex organic molecules. Without these icy gifts, oceans may never have formed, and the chemistry of life may never have begun. Thus, what ancient eyes saw as omens of death may in fact have been bringers of life, guardians disguised as monsters. Some comets flare unexpectedly when their surfaces crack, exposing new ice to sunlight. These sudden outbursts can increase their brightness tenfold, catching astronomers by surprise. To witness such a burst is like seeing a star awaken in slow motion, a faint smear becoming a luminous beacon. These moments of volatility remind us that comets are not passive relics but living bodies, changing and unpredictable, always with more to reveal. The long tails of comets act like cosmic wind, revealing the invisible solar wind. As streams of charged particles from the sun push against cometary gas, the tails ripple and bend, giving us a visible map of forces otherwise unseen. Each comet is both a spectacle and an instrument, showing us the reach of the sun's breath. In their shimmering veils, we see evidence of the star's power stretching across millions of kilometers. Sometimes comets disintegrate completely, leaving behind only trails of dust. These trails become meteor showers when Earth passes through them, creating annual spectacles like the Perseids or Leonid. Thus, even in death, comets continue to give. They transform into fireworks for future generations, streaking across the night sky as reminders of their journeys. In this way, they achieve immortality not through survival, but through legacy. In deep time, some comets become bound companions of the Sun, their orbits stretching thousands of years. These long-period comets may only appear once in human history, making them singular events. When one graces the sky, it carries the weight of ages. A traveler who last appeared when mammoths walked the Earth. To see one is to share a moment with countless ancestors, united by a light older than memory. Comets serve as portals into planetary science. By striking moons and planets, they deliver new elements and leave craters that record impacts like scars. These scars reveal the history of bombardment across the solar system, painting a violent portrait of early days. Each crater is a signature, each basin a fossil of catastrophe. The bodies we explore today are shaped in no small part by cometary fists from the sky. When a comet falls apart, its fragments may follow nearly identical orbits, arriving as a family of comets. To track them is to watch the lineage of a celestial body scatter across centuries. Some fade quickly, others persist. The family line continues, a testament to survival through division. It is a form of inheritance unlike any we know, continuity born not of growth, but of shattering. Astronomers sometimes describe comets as time travelers, their icy shells shielding matter that has not seen sunlight in billions of years. When a comet nears the sun, it is as if that frozen past awakens, releasing gases trapped since the dawn of the solar system. Each molecule is a messenger from an era long gone, carried across space and time to whisper its story. To study a comet is to listen to voices of the deep past. The path of a comet can be altered by outgassing jets that act like thrusters, subtly changing its orbit. These shifts, though small, accumulate, making cometary trajectories notoriously difficult to predict. They are creatures of chaos, guided partly by physics, partly by chance. Their own breath steers them, turning them into sailors of the void, adjusting course without intention, yet always moving forward. Comets sometimes appear with more than one tail, their dust and ion tails separating visibly in the sky. The dust tail curves gently under gravity, while the ion tail shoots straight, pulled by the solar wind. Together, they form a double signature, a glowing V in the heavens. To see this split is to witness both the sun's warmth and its wrath, expressed in light across the void. When spacecraft like Rosetta have approached comets, they revealed landscapes that look like alien sculptures. Cliffs, boulders, and sinkholes carved bizarre terrain, shaped by slow erosion of ice. These surfaces are dark, almost black, absorbing most sunlight, yet from them rise brilliant jets of vapor. It is as if comets hide their brilliance inside, releasing it only under pressure, a metaphor for hidden strength waiting to burst forth. In literature and art, comets have been symbols of impermanence, fleeting visitors that reflect the transience of life itself. Their brilliance is brief, their passage sudden, their return uncertain. They remind us that beauty is not always eternal, that sometimes what is most breathtaking is also most fragile. The lesson of comets is not to cling, but to cherish, to marvel while the light endures. Every time Earth passes close to a comet's orbit, astronomers refine our understanding of orbital mechanics. These encounters teach us how gravity, radiation, and collisions sculpt the solar system over time. Comets are not passive wanderers but active participants in shaping orbits, redistributing energy, and maintaining cosmic balance. Their movements ripple outward, affecting far more than their lonely paths suggest. When comets collide with each other in the distant Oort cloud, fragments are sometimes sent spiraling inward toward the sun. These collisions are the seeds of future spectacles, battles in the frozen dark that spark lights we see thousands of years later. A flash in the far reaches of space becomes a glow in our skies, proving that even in obscurity, distant dramas shape our world. Some cultures saw comets as divine spears piercing the heavens, weapons hurled by gods in anger or warning. To them, the tails were flames, the heads were blades. While we now know their composition, the image still resonates. Comets remain weapons of possibility, their strikes capable of reshaping worlds. The myth is not entirely wrong. They are indeed spears, though thrown not by gods, but by gravity. Ultimately, comets embody paradox. They are both fragile and enduring, destructive and life-giving, ancient and fleeting. Their presence unsettles and inspires, terrifies and delights. They are the universe's reminders that not all questions have clean answers. In their icy breath and fiery tails, they teach us to hold wonder alongside fear, to see beauty in chaos, and to remember that even the smallest fragments of creation can carry eternity within them. Comets are not merely objects in the sky. They are archives of time, holding within their frozen hearts the chemistry of the early solar system. As they drift from the distant Oort cloud or Kuiper belt, they carry pristine material that has never touched a planet. When these icy bodies awaken under the sun's warmth, they release gas and dust, allowing scientists to study conditions that existed billions of years ago, a frozen window into creation itself. Every comet's path is a narrative written in gravity, tracing arcs shaped by planets, the sun, and even nearby stars. Some comets circle repeatedly, returning like celestial pilgrims to mark the passing of centuries, while others are one-time visitors, blazing briefly before vanishing into interstellar space. Observing these wanderers is like reading an epic poem across time. where each orbit is a stanza and each tale a verse of luminous storytelling. When comets approach the sun, sublimation turns ice into gas, forming the coma and tails that dazzle observers. The ion tail streams straight away from the sun, glowing blue from interaction with solar wind, while the dust tail curves under the influence of gravity. This duality of light and form makes comets appear alive, ethereal, and constantly changing, like painters tracing strokes across the dark canvas of space with invisible brushes. Ancient civilizations often recorded comets with a mix of awe and fear. They were harbingers of events too large to control: wars, famines, or coronations. Yet they were also symbols of beauty and wonder, appearing suddenly, inspiring legends that stretched across cultures and millennia. Each sighting became both a story of the cosmos and a reflection of humanity's attempt to make sense of forces far beyond comprehension. Comets' nuclei are deceptively small, sometimes only a few kilometers across, yet they can produce comas larger than Jupiter. This contrast between tiny cores and massive glowing envelopes creates a paradoxical presence in the sky, fragile yet monumental. Their fleeting appearances remind us that even small objects can have an impact on perception, dominating the heavens for those lucky enough to witness them. Some comets carry complex organic molecules that may have contributed to life on Earth. Amino acids and sugars embedded in cometary ice suggest that these celestial travelers delivered the ingredients necessary for biology. In this sense, comets are both relics and benefactors, messengers of the cosmos that carried prebiotic material across vast distances, seeding planets and potentially enabling the emergence of life itself. The sudden brightness of a comet often comes from unexpected outbursts. A fissure in the nucleus can release gas and dust rapidly, illuminating the night sky. These moments transform a faint, invisible wanderer into a spectacle of brilliance, reminding us that comets are volatile, reactive, and unpredictable. Their unpredictable nature ensures that no observation is ever guaranteed, making every sighting a rare and precious experience. Jupiter and Saturn act as cosmic gatekeepers, altering cometary orbits through gravitational influence. These massive planets can redirect comets inward, capturing them into shorter period orbits, or fling them outward into the void. In this way, comets are constantly navigating a shifting landscape, their paths dictated by the silent authority of giants, performing an eternal ballet choreographed by the laws of gravity. Some comets are long-period visitors, taking thousands of years to complete a single orbit. These rare travelers carry the memory of civilizations long gone, of landscapes and seas that no longer exist. When such a comet appears, it bridges epoch, reminding us that time in the cosmos flows differently than on Earth. Observing these wanderers is a dialogue across centuries, a reminder of humanity's fleeting presence in comparison to cosmic cycles. The dust in comet tails reflects sunlight, creating spectacular luminous streaks. Each particle is a frozen fragment from the early solar system, traveling millions of kilometers to meet our eyes. Meteor showers result when Earth passes through these dusty remnants, linking past comets to present observers. In this way, every falling star is a fragment of history, a tiny testament to journeys that began long before humanity existed. Comets' surfaces are often dark, coated with organic compounds that absorb sunlight. Despite their brilliance, the nucleus is a shadowy object, hiding its ices beneath a tar-like layer. This contrast between light and dark adds to their mystique, turning a simple frozen body into a celestial enigma. The brilliance we see is often born from the comet's destruction, revealing that beauty sometimes emerges from decay and vulnerability. Sun-grazing comets, those that pass extremely close to the sun, can experience extreme heating and tidal forces. These encounters often result in dramatic disintegration, flaring brightly before vanishing. Their sacrifice lights up the inner solar system, offering rare and brilliant spectacles. Through these deaths, comets demonstrate impermanence and the ephemeral nature of even the most majestic celestial objects. Comets that break apart can create temporary families of fragments, each tracing slightly different paths. These fragments may persist for centuries, contributing to repeated meteor showers or visible streaks in the sky. In this way, the death of a comet is not an end but a multiplication, scattering light and history across time, and reminding us that even destruction can give rise to enduring beauty. The icy shells of comets preserve isotopic signatures that tell stories about the early solar system. Deuterium levels, noble gases, and other isotopes allow scientists to reconstruct formation conditions, offering clues about where comets formed and how the Sun system evolved. Each frozen nucleus is thus both a relic and a laboratory, a repository of information spanning billions of years. Interstellar comets, like Oumuamua and Borisov, are travelers from beyond the solar system. These brief visitors hint at a galaxy filled with icy wanderers, connecting distant star systems in a shared cosmic story. Their presence expands our perspective, reminding us that comets are not merely local phenomena, but universal actors, carriers of matter and history between suns. The rotation of comets can influence their activity. Spin rates expose new areas to sunlight, triggering jets and eruptions. Some comets spin so rapidly that they fragment under centrifugal force, scattering debris across space. Observing this behavior provides insight into their internal structure and the forces at play, turning comets into dynamic, living entities whose motion is both guided and unpredictable. Ancient observations of comets, preserved in texts from China, Babylonia, and Europe, allow modern astronomers to reconstruct long-term orbits. These historical records bridge past and present, showing continuity in celestial patterns. They remind us that human fascination with comets is timeless, and that our ancestors shared the same awe and curiosity we feel today under streaks of ice and dust. The interaction of comets with solar radiation can create unexpected phenomena, such as sodium tails that glow bright yellow. These unusual features offer additional clues about the chemical composition of the comet and the physics of the solar wind. Every new tail discovered adds to the complexity of these wanderers, revealing that no two comets behave identically, and that even familiar objects hold secrets yet unseen. Comets can also harbor magnetic minerals within their dust, carrying records of the magnetic environment of the early solar system. By studying these minerals, scientists uncover information about the Sun's ancient magnetic field and the forces that shaped planetary formation. In essence, comets are tiny magnetic historians, keeping records of invisible forces that influenced the birth of worlds. Each comet represents a bridge between destruction and creation. Their impacts can devastate, yet they also bring water, organics, and energy. Their very existence challenges the distinction between danger and benefit, reminding us that the universe is rarely binary. To follow a comet's journey is to witness both peril and possibility. Light and shadow, chaos and order intertwined across space and time. Comets are time capsules, preserving the primordial chemistry of the solar system within their icy cores. As they journey through the cold darkness of space, they remain largely unchanged for billions of years. When they approach the Sun, the heat triggers sublimation, releasing gas and dust that form glowing comas and tails. In this way, comets offer a direct connection to the conditions and materials present at the very dawn of our planetary neighborhood. The dust tails of comets trace paths sculpted by solar radiation, pressure, and gravity, creating beautiful arcs that can stretch millions of kilometers. Each tail is a map of particles, each particle a messenger from the early solar system. When Earth passes through these dusty streams, meteor showers light up the night sky, turning invisible relics into dazzling displays. In this way, comets transform ancient history into living spectacle visible to all. Comets sometimes harbor complex organics and amino acids, suggesting that these icy travelers may have seeded life on Earth. Every close approach brings the possibility that they deliver molecules essential for biology. By studying the composition of comet dust and ice, scientists are piecing together how life's building blocks may have arrived from space, highlighting the role comets play as both cosmic archivists and potential bearers of life. A comet's nucleus may be small, but its activity creates enormous structures visible across vast distances. Gas and dust escaping from the surface form the coma, often thousands of kilometers wide, and the tails can extend millions of kilometers. These glowing envelopes magnify the comet's presence far beyond its actual size, allowing tiny objects to dominate the sky and capture the attention of observers across the planet. Ancient astronomers often feared comets as harbingers of catastrophe, yet modern science reveals them as both dangerous and generous. They can bring destructive impacts to planetary surfaces, yet they also deliver water, organics, and other vital compounds. Comets are dual agents of the cosmos, reminding us that creation and destruction are intertwined, and that phenomena that inspire fear may also foster life and beauty. Sun grazing. Comets offer some of the most dramatic celestial displays. As they skim close to the sun, their surfaces vaporize intensely, forming brilliant tails and plumes. Some survive the encounter, continuing on elongated orbits, while others are torn apart, disappearing entirely. These events are fleeting but unforgettable, a visual testament to the power and fragility of celestial wanderers as they confront the overwhelming energy of a star. Comets are shaped by their journeys. Repeated passes near the sun can erode surfaces, carve deep fissures, and expose fresh ice. This reshaping produces bursts of activity that alter brightness and tail morphology. Each comet thus tells a story of transformation, showing that even in the cold void, change is inevitable, and that a single body can carry a complex history of interactions with its environment. The composition of comet tails varies, containing ions, neutral gases, and dust of varying sizes. These mixtures produce different colors and forms, from blue ion tails to golden dust streams. Observing these differences allows astronomers to decode the chemical and physical processes occurring on the comet, turning each tail into a natural experiment that illuminates conditions far beyond Earth. Interstellar. Comets occasionally pass through our solar system, bringing clues about distant planetary systems. Unlike comets bound to the sun, these visitors travel on hyperbolic trajectories, briefly gracing our skies before disappearing forever. Their fleeting appearances connect us to a larger galactic story, reminding us that our local system is part of a vast, interconnected cosmic web filled with icy wanderers from distant stars. Comets can break apart due to rapid rotation, solar heating, or tidal forces during close approaches to planets. These breakups produce multiple fragments, each carrying part of the original nucleus forward. Observers may see clusters of mini-comets following the same trajectory, creating dynamic and transient celestial displays. In this way, comets demonstrate both resilience and vulnerability, transforming destruction into extended spectacle. The study of cometary isotopes, like deuterium and noble gases, provides insight into the origins of water and atmospheric evolution on Earth. By analyzing the ratios of these isotopes, scientists reconstruct histories of formation and migration, learning whether comets contributed significantly to oceans and life. In this way, icy wanderers become not only spectacular displays, but also essential keys to understanding planetary evolution. Cometary comas can expand enormously as they approach the sun, sometimes dwarfing planets in apparent size. Within these vast envelopes, gases interact with solar radiation and the solar wind, producing aurora-like glows and even magnetic effects. Observing the coma is like watching a dynamic ecosystem in space, where physics, chemistry, and energy interact to create a constantly shifting display. Meteor showers on Earth are direct consequences of cometary trails. As the planet intersects with debris streams, countless particles enter the atmosphere, producing shooting stars visible across the globe. Each shower is a historical echo, a tangible link to a comet's orbit millions of kilometers away, reminding us that celestial events can have persistent effects long after the original body has passed. Comets often carry a dark, crusty layer on their surfaces, composed of complex organics and dust. Beneath this shell lies pristine ice, preserving the molecular fingerprints of the early solar system. When the crust cracks, fresh material is exposed, creating jets of gas and dust. These eruptions provide a rare glimpse into the comet's internal structure, revealing secrets hidden for billions of years. Even tiny cometary fragments can produce spectacular meteors. These particles, sometimes no larger than a grain of sand, vaporize in Earth's atmosphere, creating streaks of light. Each meteor is a messenger from the distant past, a fragment of cosmic history burning briefly for our observation, linking the night sky with the distant reaches of space where comets roam. Comet tails are shaped not only by solar wind but also by magnetic fields. Charged particles in the tail interact with the sun's magnetic environment, producing twisted or braided patterns. These intricate structures reveal not only the composition of the comet, but also the invisible forces at work in the heliosphere, turning comets into luminous instruments mapping space weather. Long-period comets, with orbits spanning thousands of years, are like celestial time travelers. Their rare returns allow humanity to witness events that were last seen by ancestors long gone. Observing such comets connects generations across millennia, reminding us of the vast scales on which the universe operates and the transient nature of human lifetimes in comparison to cosmic time. Comets can illuminate the night sky even during twilight. Their brilliance can rival Venus, creating an ethereal glow that captivates observers. These rare appearances remind us that light in the cosmos is relative, that even small objects can dominate perception when conditions align. Comets are masters of spectacle, orchestrating moments of awe across Earth's surface. Some comets carry material that predates the formation of the planets, preserving molecules from before the sun ignited. These primordial ices are untouched by planetary processes, offering scientists a direct link to the molecular cloud that birthed the solar system. By studying them, we glimpse conditions that existed before Earth, before life, before history itself, connecting us to a time beyond imagination. Comets are cosmic timekeepers, holding clues to events from billions of years ago. Their frozen cores trap gases and dust that have remained unaltered since the solar system's birth. Each journey toward the sun releases this ancient material, offering scientists direct evidence of the conditions that prevailed before Earth even existed. They are both relics and storytellers, whispering secrets across the void. The tails of comets are not static. They change shape as the comet moves, interacting with the solar wind and magnetic fields. Ion tails glow blue, tracing charged particles accelerated by the sun, while dust tails curve under gravity's influence. Watching these luminous arcs is like reading a living diagram of space physics, a dynamic portrait of forces that are otherwise invisible to human eyes. Some comets carry organic compounds that predate life on Earth. Amino acids, sugars, and simple hydrocarbons embedded in the ice suggest that comets may have delivered critical ingredients for biology. Each approach of such a comet provides an opportunity to study the molecules that could have contributed to life's origins, turning these icy wanderers into cosmic chemists and potential bearers of life. The size of a comet's nucleus is deceptive, though often only a few kilometers across. The coma and tails can extend millions of kilometers, dwarfing planets in apparent size. This contrast between a small, solid core and massive glowing envelopes reminds us that appearances can be misleading, and that even the tiniest celestial bodies can command attention across the sky. Sun-grazing comets face extreme conditions near the sun, with intense heat and tidal forces often tearing them apart. Their disintegration produces dazzling displays visible from Earth, brightening the sky with sudden brilliance. In their destruction, they demonstrate both fragility and grandeur, transforming danger into spectacle and showing the fleeting beauty of cosmic encounters. Comets sometimes fragment into multiple pieces, forming temporary families that follow similar orbits. Observers may witness clusters of glowing objects tracing the same path across the sky. These fragmentations illustrate resilience through multiplication, as a single comet can spawn new celestial phenomena, extending its legacy across space and time. The icy layers of comets preserve isotopic ratios that inform scientists about the solar system's early chemistry. By studying these frozen records, researchers can reconstruct temperatures, pressures, and molecular compositions from billions of years ago. Each comet is thus a natural archive, offering insights into the building blocks that shaped planets and influenced the development of life. Comets travel at incredible velocities, often tens of kilometers per second, yet appear to drift gracefully in the sky. This illusion of calm masks immense energy and rapid movement, highlighting the disconnect between human perception and the true scale of cosmic motion. To watch a comet is to witness controlled chaos, a small object racing through vast distances, yet seeming serene to distant observers. Meteor showers are the lingering signatures of comets. When Earth passes through the debris left behind, countless particles ignite in the atmosphere, producing spectacular streaks of light. Each meteor is a fragment of a comet's journey, a tangible connection between the distant past and the present sky, allowing humans to experience the comet story firsthand. Ancient astronomers documented comets with remarkable detail, noting tails, motion, and brightness. These records provide modern scientists with invaluable data, helping reconstruct long-period orbits and identify recurring comets. The fascination with these celestial wanderers transcends time, linking modern observers with civilizations thousands of years ago. United in awe of the night sky. Comets are sculpted by repeated solar encounters, Sublimation of ice creates jets that carve cliffs, pits, and fissures, altering surfaces over time. This reshaping produces unpredictable outbursts and brightness variations, reminding us that even small celestial bodies are dynamic and constantly evolving under the influence of stellar radiation and gravitational forces. Cometary dust is a mix of minerals, organics, and frozen volatiles. These particles reflect sunlight, producing spectacular tail formations. As Earth intersects these streams, meteor showers reveal the past paths of comets, linking microscopic particles to massive celestial journeys. The night sky thus becomes a canvas displaying the echoes of ancient wanderers. The brightness of comets can change dramatically. Outbursts, fragmentation, or exposure of fresh ice can turn a faint object into a brilliant spectacle. This unpredictability ensures that every comet is a unique performance, a fleeting show that cannot be fully anticipated, keeping observers and scientists alike in a state of wonder and expectation. Comets are irregularly shaped, often resembling lumpy potatoes or elongated spindles. These forms affect rotation, sublimation, and jet formation. Studying their shapes allows astronomers to understand the physical forces shaping these bodies, revealing the interplay between internal structure and external forces that govern their behavior across the solar system. Some comets are interstellar visitors, passing through the solar system only once. Their hyperbolic trajectories and unique compositions hint at conditions in distant star systems. These travelers expand our perspective, showing that comets are not confined to one neighborhood, but are part of a galaxy-wide population, bridging worlds with icy messengers that illuminate paths far beyond our sun. Comet tails are shaped by magnetic fields, as well as solar radiation. Charged particles in the tail interact with the sun's magnetic environment, creating intricate twists and braids. These structures provide insight into both the comet's composition and the invisible forces that permeate space, turning comets into natural instruments of cosmic observation. Long-period comets connect humanity across generations. Their rare returns allow modern observers to witness phenomena last seen by ancestors centuries or millennia ago. This temporal link reminds us of the vast scales of cosmic time, where human history is brief and celestial cycles continue unabated, tracing patterns that transcend individual lifetimes. Comets sometimes carry magnetic grains that record ancient solar activity. These particles allow scientists to study the early sun's magnetic field and its effects on the solar system's formation. Each comet thus functions as both a celestial messenger and a historian, preserving evidence of forces invisible yet fundamental to planetary evolution. The eruption of gas and dust from comets creates spectacular jets, illuminating surface features and revealing internal structures. These outbursts offer rare glimpses into the inner workings of these frozen worlds, showing that comets are not static relics but active, evolving entities capable of dramatic displays when heated by the sun. Even after passing the sun, comets leave behind debris that continues to influence the solar system. Meteor streams, dust clouds, and gas trails remain for millennia, producing recurrent showers and subtle interactions with planets. These remnants ensure that a comet's legacy extends far beyond its visible appearance, making them agents of lasting influence across space and time. Comets are cosmic storytellers, carrying secrets from the edge of the solar system to our skies. Their journeys span billions of kilometers, often taking millions of years. Each approach to the sun transforms them, releasing gas and dust that form luminous tails. These tales are not mere decoration, they are pages in the comet's autobiography, chronicling interactions with radiation, gravity, and the solar wind, a living record of cosmic history. Some comets have highly elliptical orbits, traveling close to the sun and then retreating to the outer reaches of the solar system. This repeated exposure to solar heating carves features into their surfaces cliffs, pits, and fissures that shape future out. In a sense, comets are sculpted by their own journeys. Their physical forms are a product of the cosmic environment through which they travel, revealing that even in emptiness, forces of change are constant. Cometary outbursts can release more energy in a single moment than entire cities consume in years. Jets of vapor and dust erupt violently from their surfaces, creating temporary, spectacular brightening. These unpredictable bursts make comets challenging to study, yet they offer rare glimpses into the dynamics of sublimation and the internal structure of these icy bodies, turning turning each observation into a scientific treasure hunt. Comets sometimes fragment under the stress of solar heating or rotational forces, creating families of smaller comets. Each fragment continues along similar orbits, forming clusters visible to observers with telescopes. These miniature comet families provide insight into the processes of celestial breakups, illustrating that even destruction in space can lead to renewed displays of beauty and complexity. In the night sky, the coma of a comet can be vast, larger than planets, yet composed of tenuous gas and dust. This glowing envelope reacts with sunlight and the solar wind, producing dazzling effects observable across millions of kilometers. A tiny nucleus can appear insignificant compared to the grandeur of the coma and tail, a reminder that appearances are deceptive, and that even small objects can command the attention of the cosmos. Some comets carry high concentrations of noble gases like argon and xenon. These gases, trapped in ice since the early solar system, offer scientists clues about the formation conditions of the Sun and planets. By studying them, researchers reconstruct the temperature, pressure, and chemical environment of regions far beyond the reach of Earth, turning comets into natural laboratories of ancient physics and chemistry. Comets can travel at astonishing velocities, often tens of kilometers per second. Despite this speed, from Earth they appear to drift gently, their paths traced over nights or weeks. This illusion of calm belies the immense energy contained in these objects, reminding observers that appearances in the sky can be deceptive, and that the universe operates on scales far beyond human intuition. Sun-grazing comets, when passing near the Sun, sometimes survive multiple close approaches. Each passage alters their shape and spin, creating complex surface features and unpredictable activity. These daring travelers demonstrate resilience and adaptation, navigating intense forces that would shatter weaker bodies, highlighting the incredible endurance of small icy worlds against the immense energy of stars. Meteor showers are the ephemeral legacies of comets. Each tiny dust particle entering Earth's atmosphere burns brightly, linking a fleeting streak of light to a body billions of kilometers away. The annual return of showers like the Perseids or Leonids is a reminder that comets leave trails that persist long after their visible appearances, transforming moments of destruction into enduring spectacles. Comets have been catalogued for millennia. From Babylonian clay tablets to Chinese imperial records, ancient observers noted their tails, color, and motion, often associating them with omens. Today, these records provide astronomers with data to reconstruct historical orbits and understand long-period comet behavior, bridging human history with celestial mechanics and demonstrating that fascination with these wanderers is timeless. The icy nuclei of comets preserve molecules that existed before Earth formed. By analyzing their composition, scientists uncover the ingredients present in the early solar nebula, learning how organic compounds were distributed throughout the forming planetary system. Each comet becomes a frozen time capsule, offering direct access to preplanetary chemistry that shaped the conditions for life on Earth. Comet tails can curve, twist, and sometimes even form multiple strands. The combination of solar wind, radiation pressure, and magnetic fields creates complex patterns that appear almost artistic. Observing these shapes provides insight into the physics of plasma, particle motion, and light interaction, turning each cometary display into both a scientific dataset and a visual spectacle that inspires wonder and curiosity. Comets occasionally carry magnetic minerals within their dust. These grains record the orientation and strength of the solar system's early magnetic field, preserving evidence of forces that influenced planetary formation. By studying these magnetic traces, scientists can reconstruct aspects of the Sun's ancient behavior, transforming comets into natural recorders of invisible cosmic phenomena that occurred billions of years ago. The interaction of comets with solar radiation can produce sodium tails, a faint yellow glow that differs from the traditional blue or white tails. These subtle features reveal the diversity of materials within comets and their reactions to sunlight. Observing such phenomena adds depth to our understanding of cometary chemistry, showing that every comet carries unique signatures waiting to be discovered. Long-period comets may only return once in a human lifetime, or even millennia. Their appearances bridge epochs, connecting modern observers with distant ancestors who witnessed the same lights. These visits serve as temporal anchors, reminding humanity of its fleeting presence against the backdrop of cosmic time. and emphasizing the continuity of celestial events over scales far beyond human comprehension. Comet nuclei are often irregular in shape, resembling potatoes, lumpy hills, or even elongated spindles. These forms influence how gas and dust are released, creating asymmetrical jets and uneven activity. Studying these shapes helps scientists understand cometary physics, from rotation and sublimation to internal structure, turning each comet into a case study of nature's diversity and ingenuity. Some comets are interstellar in origin, arriving from beyond the Sun's gravitational influence. These travelers bring information about other star systems, carrying materials that never formed in our solar neighborhood. They are messengers from distant cosmic neighborhoods, fleeting visitors that briefly illuminate our skies and remind us that the galaxy is filled with icy wanderers, sharing paths across vast distances. Comets interact with the solar wind to create plasma tails that can bend and ripple in response to changing magnetic fields. These dynamic displays are visible across millions of kilometers, offering a direct view of forces that are otherwise invisible. By observing these effects, astronomers gain insight into the behavior of solar and interplanetary plasma, learning from natural phenomena that act as cosmic laboratories. The brightness of a comet is not only determined by its size, but also by activity and proximity to the Sun. A small nucleus can sometimes produce a spectacular display if gases erupt explosively, while larger comets may remain faint. This unpredictability ensures that comets are always a source of surprise, keeping astronomers and skywatchers alike eager for each new visitor to reveal its character. Even after a comet passes, its trail of dust can influence Earth for years, producing recurring meteor showers. These ephemeral trails preserve the memory of the comet's journey, linking fleeting streaks of light to bodies long vanished. Each meteor becomes a messenger, a spark of ancient history lighting up the present sky, and reminding us of the enduring impact of these transient travelers.